Hello everyone, this is Guru Prasad KN, Assistant Professor, ATME College of Engineering, Mysuru. Today in this video, I will be demonstrating how to use an op-amp as comparator using Multisim. The aim of this experiment is to study and verify the operation of op-amp comparator under two conditions. One is using zero reference voltage and the second one is for non-zero reference voltages. And in both the cases, we will obtain and analyze the hysteresis curve. And the objective of this experiment is to simulate the op-amp comparator in Multisim and observe its output response for varying input signal and reference voltages. This is the circuit diagram which we will be drawing using Multisim. So in the circuit diagram, we can find we have an op-amp. I am choosing MUA 741, a commonly used op-amp, two power supplies plus VCC and minus VEE, and I need an AC power source, a resistor of 10 kilo ohm, and to check the output I will be using signal oscilloscope. Now let me draw the circuit using Multisim. So I'll open the Multisim now. So first let me press Ctrl W. So once you press Ctrl W, you will get this screen. So there you can go for analog. In analog you can choose op-amp. In op-amp you can choose 741. Initially it will show like that. So if you type 741, you will get 741 and you can pick and drop it. And we also require power source. So I will go to the sources, there signal voltage source, and I will choose AC voltage. And I also require ground signals. So I will go to the power source, there I will pick ground and require nearly some 3 to 4 ground. So I will keep all these things initially. And I also require a resistor. I will go to basic, I will choose resistor, and you can choose the value of 1 kilo or 10 kilo, and you can drop here. And I require again plus VCC and minus VEE. I will go to the sources. In a power source I have VCC, and I have VEE, that is minus VEE. And I also require an output device. In the right side palette you can pick oscilloscope and you can place here. And let me reverse it. You can use Ctrl R, and let me change VCC value to minus 12 volt and minus VEE to minus 12 volt, and rotate this resistor 10 kilo ohm, and let me change the input value to 5 volts, approximately 100 hertz. And once all the changes have been done, now you can make the connections. So I'll connect input source to the non-inverting terminal, pin number 3, and other terminal is grounded. So pin number 2 is grounded directly because I am doing the first one, that is op-amp comparator with zero reference. So in pin number 2, directly connected to the ground. Then pin number 7 to plus VCC, that is plus 12 volt. Pin number 4 minus VEE, minus 12 volt. And pin number 6 connected to the load resistor of 10 kilo ohm, and other side connected to the ground. Then I am using a oscilloscope to observe the output. I will be using both the channels A and B. In one channel I will see the input and other channel I will see the output. So negative of both the channels I am connecting to the ground. So I am connecting channel B to the output and channel A I will connect it to the input. So for the clear view I am changing the output pin color to the wire collector to the blue color. Now once all the connections have been done, then click on run, double click on CRO, and you can change this time base. You can reverse this one and you can press on single. So this is the output what I am observing on the screen. So the red color one is the input signal, the sinusoidal input, and the blue color one is the output signal. So whenever input signal crosses zeroth line, whenever it is positive, the output is plus V saturation, and whenever input is negative, the output is minus V saturation. So you can clearly observe both this input and output line are crossing at zeroth line. So this is the point. So this one we also call it as ZCD, zero crossing detector. The reason why these both the waveforms are crossing at zero line is we have given pin number 2 directly to the ground. Now I will check the hysteresis. So click on B by A. You can see the hysteresis here. So frequency I have given 100 Hz. So can reduce this value. So let me double click on the signal source, make it 10 Hz. Then we can see, you can see the hysteresis curve. Fine. So I can pause this one to see the output. So here we can see whenever the input is positive, the output is plus V saturation. Whenever the input is less than 0, the output is minus V saturation. So this is regarding the op-amp as comparator using zero reference. Now what I will be doing is I will make some changes to this particular circuit. So instead of using pin number 2 directly to the ground, I will be connecting a DC power supply. So before that one, let me change the frequency back to the 100 Hz. Then press Ctrl W, go to the power source, take one DC power. So keep here. Then I will connect this ground on the other side. So connect one end of the DC power supply to pin number 2, other end to the ground, and V2 change it to 2 volts. Now I will run this particular circuit. So double click on this one and we can see the red color one is input, the blue color one is output, and they are crossing at plus 2 volts. So earlier both were meeting at reference line, but now it is above the reference line, plus 2 volts above the reference line. Now for the same thing, you can check the hysteresis curve. Click on B by A. Here we can see it is shifted 2 volts in the positive side. The hysteresis curve shifted 2 volts towards the positive side. Now in the similar manner, instead of 2 volts, so you can also change it to minus 2 volts. And you can see the output now. So now the waveform will be shifted downwards. So here we can see the output is shifted downwards by minus 2 volts. So this is how we're going to check op-amp as comparators. for both zero reference and non-zero reference. Thank you for watching the video.